Hello, my dear students. Welcome back to the lecture. So in this lecture, we'll try to see how to understand the plinth beam layout, and we'll try to see that. Okay. So right now, I'll take you to the plinth beam layout. So this is how the plinth beam layout is given. Yeah. So how do you put the plinth beam layout? For that, we need to understand. Okay. We have a columns everywhere, right? So whenever we put the plinth beam, we should make sure, I'll write it here. The first step, always we should make sure that we are connecting column to column, connecting connecting column to column. So what do you mean by this? That means whenever I put a beam, my main intention is to connect the column to column, or you can say tying of column. Okay, it's called as tying of column, or you can say connecting column to column. So that means now I have a column here, so I need to connect this with a beam. Okay, so I'll do it in this way quickly. So let me take one color. Yeah, so I'll connect this. So this is one beam for me, right? Again, I have a column here, I'm going to connect this with a beam. Got it? I have a column here, I connect this with a beam. So this is a typical way of drawing a plinth beam. Of course, you have to do it in the AutoCAD, but anyhow, basics are basics. We'll try to understand the basics. Then doing it in AutoCAD is not a big deal. Again, from here to here, I'll connect with a beam, and from here to here, I'll connect. Of course, I have to do in this way, and then from here to here. Got it? So these are the fundamentals you need to understand whenever you put the plinth beam layout, or whenever you do a plinth beam. This is a basic understanding we are supposed to have. Again, I have a column here, so let me put a beam here, and I have a column here, let me put a beam here. Got it? Yeah, now I'll make use of a different color just to differentiate. Now again, from here to here, I'll connect with a beam. Okay, I'll connect from here with a beam, I'll connect here from a beam, and from here to here, I'll connect with the beam, and I'll connect a beam. See, wherever you have column, you have to connect that with a beam, and that is the main logic. Again, I have a column here, connect that with a beam, and of course here also I have, so I'll connect that with a beam. Got it? Again, of course, we are supposed to do it here also. Yeah, good. So this is how a plinth beam layout looks. So this is a basic understanding what I have done, and for the same drawing, we'll see that how the structural engineer has done that. Now you can give the naming to this. Now naming can be anything, but the usual practice what we follow is that we'll start from left to right, the naming, and then from bottom to top. So this is a typical pattern we are supposed to follow when we write the names for the beam. Again, it all depends. You can even follow right to left, you can even follow the top to the bottom, but most of the engineer prefer left to right and bottom to top. So what do you mean by left to right and top to bottom to top? That means I'll give a name to this. I'll write this as PB1. That means plinth beam 1. So I've started from the left. First, I'll finish the horizontal beams. Again, where is my horizontal beam? So my next horizontal beam is here. This is vertical. This is horizontal. So I'll give this as PB2. Got it? It can be anything. I'll give this as PB3. I'll give this as PB4. I'll give this. Okay. I did one mistake. Actually, this is PB1. This is the second horizontal, right? Because this is next to that. I'll quickly change it out. So what I'm supposed to do is, yeah, let me quickly change them. So this is PB3. Okay. This should be PB4. This should be PB5. And now I'll write here PB2. Got it? PB2. So PB1, PB2, 3, 4, 5. We don't have any horizontal beams here. I'll give this as PB6. PB6. This will be PB7. This will be PB8. This will be PB9. That means plinth beam 9, and this will be my PB10. So all my horizontal beams I have covered. I'll go to the vertical. So vertical, you have to start from bottom to top. Yeah, so where is from a bottom to top? This is my bottom, isn't it? And this is top. So I'll give a name to this. Again, I'll go from left only. You can start even from here also, but we are following this left to right and bottom to top. So again, from the left side only I'll start. So this becomes my PB11. This becomes my PB12. This becomes my PB13. And then, okay, this is PB13. This is PB14. This becomes my PB15. This becomes my PB16. Okay, I should have used a different color. It's okay. PB16. This is PB17, and this is PB18. Yeah, I'll change the color to that. Okay, so PB11, 12, got it. So this is a typical way we try to name the uh, Plinth beam. Now we'll see what exactly the structure engineer has done. Now you can see it here. Whatever I've done, no, the same thing the structure engineer has done it. Provided you can see here it has come PB18. This is PB17. We also have named it as PB18 and PB18. Okay, PB17. And then you can see we started from here, isn't it? PB1. And again, you can see this is also PB1. Then we have given PB2. This is also PB2. Then he has given this as PB3, PB4, and PB5. Right. So I'll try to delete it out once and then we'll go there. I'll delete this. Yeah, now you concentrate here. See, PB1 is given. Then he has given this as PB2, PB3. He has given this as PB3A. That also you can do, but you can give it as PB4 also, no issue in that. Then this is PB4 he has given. And again, he has come here, PB, yeah, after PB4, he has named this as PB5. Okay, we missed this one beam. Yeah, I should have done one beam here, no issues. And we are learning. Actually, what happens from this is a place where your staircase starts, right? So always remember, wherever your staircase starts, isn't it? You have to give one beam there, so that what will happen? You can take the double bar from here. Okay, we'll see what is double bar. Okay, just try to understand. So this is you can see it here, no? Leave double bars at so and so. We'll come to this a bit later. So from here, your double bars will come, and from here, entire load of a staircase will be transferred to this particular beam. So that is why we have to give one beam here. I had missed that beam. It's okay. So PB5, then PB6, PB7, PB78, PB8, and PB9. Then you see has come here PB10, PB11, 12A, and 12, 12, 12A, then 13, then 14, 15, 16, 17, and 18. Got it? So this is a typical way of doing a plinth beam layout, and this is a typical way of doing a plinth beam frame layout. So whichever drawing you take from here onwards, this is the usual thing what we follow, and I hope you up to here your concepts are clear. Now what they have done is they have given a name to this. I mean the sizes. We gave only PB1. So what these people have given, they are told that the size is 9" by 18". This also 9" by 18". Everywhere it is 9" by 18". Now the question is that how did they tell that this is 9" by 18". So there is no such thumb rule. So what we usually do is that through our experience, we can go with this logic. Otherwise, you can start to give the size of your beam right from 9" by, for if it is a residential or a commercial, you can give 9" by 15" beam size. That is 9 inches of width, 15 is the depth of your beam. And you can try to do the analysis with help of a ETABS software and all. And if you feel the load coming on that is sufficient enough to take care of that, you can proceed with that. Maybe here they might have tried with 9" by 15", and they might have found that some of the beams were failing. If you had taken my ETAB course, or if you had taken my earlier drawing reading course, I have shown you how the beams load will be applied and all. Here we'll not try to do the same thing here, since our main intention will be try to see the different drawings and the advanced drawing. So they might have done that, and they might have, I mean, few of the beams might have failed. So that is why the next size is that always we try to increase the depth and not the breadth of the beam most of the time. So they have gone with a 9" by 18", and that is why you can see everywhere it is 9" by 18". Just in case even 9" by 18" was failing, they could have tried with 9" by 21". But usually for the plinth beam and all, we don't go with the 9" by 21", since only the wall loads are going to get transferred here, and no slab loads are going to come, since it's at the plinth beam level, provided there is no grade slab. Got it? So this is a typical idea you need to understand whenever you do the plinth beam framing. Got it? Yeah. So I think most of the things I've covered here about the sizes and all. And yeah, so that was all about the plinth beam layout. And you can see all the sizes. Now, sometimes what happens, usually in the plinth beam, we don't try to vary the size. That means you see, everywhere we are given a 9" by 18", right? What we could, actually this 9" by 18" is actually not required. Let us say somewhere at this place, 9" by 18" is not required. Or let us say somewhere here, your 9" by 18" is not required. 9" by 15" was sufficient here. So usually what we do, we see the majority of the beams. Let us say, I'll give a small example. See, let us say we have 18 beams here, right? We have 18 beams, because PB18, let us consider we have 18 beams. So in 18 beams, let us say 14 beams, you require a size of 9" by let us say 18 inches. Okay. And let us say the remaining four beams, you require a size of 9" by 15". So for these four beams, we don't try to change the size, because why? Doing it on the paper is very easy. I can do it directly on the paper and write and give it. But the person working on the side, it will be difficult for him, because he has to see the drawing. He has to be very careful while doing the execution. And if you do it for 9 inch by 15 inch, again, you have to cut the shuttering board, because 18-inch shuttering board you have to put for the plinth beam layout. I mean, for preparing a plinth beam. Again, if you want to prepare this 9 inch by 15 inch, again, you have to cut the board, or accordingly, you have to make the size. So keeping execution point of view, usually for the plinth beam, what we try to do, even though there is no requirement in some of the beam, this size is not required, we try to keep all the sizes uniform. So that is why practically whenever you see the plinth beam layout, most of the cases I'm telling, there is no hard and fast rule that same thing has to be implemented, but most of the cases what we do, we try to keep it same even though there is no requirement. So that is why you can see the same has been reflected here. Everywhere we have kept it as 9 inch by 8 inch. Maybe here it was not required, but still we have given it. It's okay for us, because we always want to be a bit economical, and also to be on the safer side, and also keeping execution point of view to make the things easier for the executing engineer. I mean, for the site engineer, we try to do all these things. Yeah. So again, now coming to this part. So I've explained you about the double bar. If you want, I'll be showing you about what is double bar. Okay. Already, if you have taken my site engineering course and the drawing reading, I've shown you many number of times what exactly a double bar is. From this beam, we try to insert all this rebar. So these are called as double bar. Here we have to make use of a 12 diameter bar at 6 inches center to center spacing. That means the distance between these two rebar has to be 6 inches, 6 inches, 6 inches. And this is your 12 diameter bar you're supposed to use. Got it? So this is how the entire plinth beam layout looks, and that is how it is. Yeah, we need to understand one more thing here. You can see here, he has given a note here. The blue one indicates beam top at below ground level, and the pink one indicates beam top at plinth level. So actually there is a difference in the ground level here. The one which is blue color, like you can see it here, this is blue color, right? The beam is blue color. All these blue beams, whatever you are putting out, that means the outer, they are at the ground level, at below the ground level. Okay. I'll show you it in the next lecture also, what exactly it looks. And beam at top, beam top at the plinth level, whereas this internal beams, this beam, this beam, this beam, and this beam, because they are pink in color, this is also pink. This being the top of this beam is at the plinth level, whereas the top of all these beams is at the ground level. So that means there's a level difference between these two beams. That means if I put it in a better way, let us say this is your beam at the outer one at the ground level. Okay, and the one which I'm showing you, okay, I'll go with the same color. So this is blue color, right? And this is pink color. I'll take a blue color first. Yeah, so this is your ground beam. Okay, and the one which is pink in color, it is at this level. Yeah, this is pink, so this is that level. Got it? So this is the level difference what we have. Okay, this is the level difference we have to maintain. So this is the top of your plinth beam, and this is your top of your plinth beam, and whereas this is your top of your ground level. This beam will come at the top of your ground level. Anyhow, in the next lecture, I'll show you this variation with the help of a structural drawings only. So I hope up to here concepts are clear, and we have understood. And also we know that why the plinth beam is given. The plinth beam is given to reduce the unsupported length of a column. If you don't give a plinth beam, then what will happen? The height of your column will increase. If the height of my column will increase, then it becomes a long column. Then again, we have to design it, then it becomes a slender column. Then accordingly, we have to do the design. So in order to avoid that, we have to give a plinth beam. That's the first reason. Second, of course, there is a brickwork load coming. So transfer the brickwork load easily, we try to give a beam. So these are two reasons why the plinth beam is to given. The main reason is to break the length of a column. To make my column as a short column, I try to give a plinth beam. Yeah. So I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture.